Good morning, everyone. I'm Gabriel. I'm working for the Swedish Institute of Space Physics, and I will present this work you are seeing in the title. It's ongoing work, so hold on, don't create too much expectations. I should be more optimistic for the future of this work. And also, questions are welcome, but suggestions are much more welcome, okay? Let me start giving a spoiler of my presentation because I think someone can be anxious and I don't know if I will fit the time, so you at least can see what I would like to present. So I will start with the framework and presenting the Alice 4D, that is the tool that we are using for this work. I should say that this is the most important part of what I will present, or the most newest part, what I will present. The fireball, yeah, is just one event that we are trying to analyze. And well, in this section, I should say something that, okay, I'm presenting here the results and I didn't figure out the best title for this. So I just put what we did so far, okay? And then I will finish with final comments. Okay, so about the framework. I'm working for this project Alice for the AUTO-SSA. This project is in the umbrella of this program. That the aim of this program is to create collaborations. In this case, it's a collaboration between the Swedish Institute of Space Physics and the Swedish Space Corporation. And this project aims to explore what we can do with this optical system that is Alice 4D in the space situation awareness, and also creating some automatic programs. One of the things that I did more in this project was exactly trying to create an automatic system to track satellites. And why this is important to say here is because we are using some of these tools that we developed during this project to adaptate on this case that we are seeing a fireball, okay? With photo actually also work with meteors, and we were very lucky because our cameras captured this event, and it's very nice. So let me start talking about our optical system. Alice 4D is placed in the north of Sweden, actually close to the three border, Finland, Norway, and Sweden. We have right now active stations just in Sweden that are these ones that are in green. So in Abisko, and this is an optical lab in Kiruna, in X-Range, in Silkmot and Chauchas. We have a baseline of between 50 and 100 kilometers between the stations. And we have a very large field of view with the cameras that I will talk more in the next slide. And just to have an idea, this is the latitude that the stations we are working are. Okay, so each station of this optical system has a high light sensitive and high resolution scientific EMCCD. We have the temporal resolution that goes up to 25 images per second. And we have 70 filters that can be placed in a filter wheel with 8 positions. This system is configured, it was developed and operates to study atmospheric phenomena like aurora, okay? So the whole idea of this project is exactly doing other things while we are studying aurora. So this is our capacity, this is our facility, but we will not choose exactly what configuration, what filter we will use, or what time resolution we will use. The idea is more or less operating in the system that is already being used for other things, okay? So presenting our tool, okay, these are the filters that we have. available for using. And I would like to show this filter. That was the filter that it was active when the event happened. So the event, and it's not playing. Okay. Okay. So this is the event we capture by our 5 stations. Maybe we're not seeing, but here everything appears in Abyssco too. Okay. So we can see that in Abyssco, it's quite complicated to see. And here you can see sometimes that it has some clothes that will be important in the future. Okay, so when we captured this event was during this time, the maximum duration by the station we had was 4.1 seconds. This was the exposure time that we are using during the time. As I mentioned, this was the filter, and this was the conditions that we capture. Okay, I will just try to pass very fast by this. Is a filter, as I mentioned, we have some tools that we developed for the other project. This filter we are using, not exactly is very effective in this case because our body is very brightness, but it's a very simple filter that I like. The simple idea is to subtract the consecutive frames, trying to remove the static objects that appears in your field of view. So this is good for removing the stars. And then we convolute and create and normalize to remove the noise. So just to have an idea, when we pass by this filter, play. When we pass the filter, we can have much more clear the image when the fireball is passing in our field of view. Okay, so we saw the object. We can also try to be as more as possible precise in the position of the object, at least in each station. So more or less in this is quite manual because I give a guess for the system, and then it fits the position with the centroid of a 2D Gaussian on the function. So it's a very simple process that more or less gives us the best coordinate accuracy for the object in each frame. And now that we have the position of the object for each frame, we also can try to find the real position of the object. For this, we have a system to calibrate our image with stars. That is a very good system. If the person that is using know how to use. And then we have we can compute the elevation, the azimuth of in each station. As you can see now, I'm working just with 3 stations. As I mentioned, there was clothes on X range that make not possible to calibrate by stars. And in Abyssco, also we had the same problem. So just a short projection. We have a simple projection, actually. We can find more or less the first point where the object appears in our field of view, and the second point, so we can have an idea of the trajectory of the object, okay? So it's more or less between Sergienko and Chauchas. If we can back in the image, Sergienko was more or less looking exactly to the position, so the movement on the field of view is very short. And then is this what we did so far? Okay, now we are in process of triangulate, because after triangulate with the 3 stations, we can try to get the trajectories, the mate velocity, origin, land regions, or something like this. This part is very we need to take care in this part a lot because we have a camera with a very large field of view, and the precision can be compromised by the size of the pixel, and then we needed to estimate very well the error. To finalize, I just should say that we are implementing now other meteors camera systems in Kiruna, and we have a good optimistic view of this, because we can merge the information that we can got with this system with the new system. Like if we try to take the spectrum with another camera, we can calibrate using the wavelength of the filter that we are using in Alice 4D. And I think my time is over. Thank you very much.